off talking about gravity. F sub g. Okay, today is 1/12/18. All right, I guess we'll come back to this. So we're going to start off talking about the force of gravity. In the problems in the book for 4A, you were given force of gravity. On the worksheet problems for 4A, you have to know how to compute the force of gravity. And yet they don't introduce force of gravity as an everyday force, I think, until like the third section, which makes no sense whatsoever. But let's talk about what gravity is. What is the force of gravity? It's a measure of how attractive you are to the Earth. More Christmas cookies, more attractive. So the force of gravity is that pull exerted. And it just happens to be equal to your mass times your acceleration due to gravity. Well, we usually refer to acceleration due to gravity as just g. So what we typically say is that the force of gravity is equal to mg. So F sub g equals mass times gravity. It's important to note here that we want to use the magnitude of acceleration due to gravity. We don't want to use a negative sign because we're just talking about the magnitude of the acceleration right now. We'll assign that negative or positive when we look at the direction in which the force is being exerted. If we're actually talking about real gravity, it's going to get an assigned value of down, which will be a negative. There are times when we end up using the magnitude, but it's not actual gravity. So we'll start to explore those in a little bit. Okay, so force of gravity on this thing is its mass times 9.81 meters per second squared. There's another force that, again, the book introduces later, but you kind of need to know it to think about these problems. Anytime you have an object that is sitting on a surface and it has a force of gravity being exerted on it, F sub g, there has to be an opposing force upward or the thing is crashing through the surface. And so if it's sitting on a surface, we call that normal force, and it's F sub capital N. That's easy. So when you get to the worksheet problems, the first couple are, somebody's holding a weight, what force is the ground exerting upward on the feet? Well, you do your sum of forces on the x-axis, you're going to find that out pretty quickly. And we'll walk through one of those when everybody starts on the sheet. The other force that comes up on the sheet, because not all objects are sitting on a surface. Can you imagine an object hanging on a hook, on a cable of some sort? You probably can. You have good imagination. There's no surface. So while there is a force of gravity downwards on this object, what's the opposing force? If this thing is not moving, there has to be a force that opposes it. Where is the opposing force, I guess, is the first question. It's in the cable. The cable is exerting the upward force. And what we call that is a force of tension. So anytime we've got a rope or a cable or a string or anything else, the force that's being exerted by that cable, filament, string, thread, hair, whatever, is called a force of tension. And it's when something's not sitting on a surface, but there's an opposing upward force that's opposing gravity. So on the problem set here, you will see that there are two force of tension problems, maybe three force of tension problems, two. And we'll do a lot more of those as we go. We do lots of force of tension problems because it's useful to know how to find that. So let's look at force of tension and angles real quick. So I've got my little block here hanging on a wire. I'm going to get rid of these. And if I wanted to figure out what the force of tension on this thing was, could I do it? Probably, yes. or we wouldn't be talking about it. So I would want to do a sum of forces on the y-axis. And I know that there are forces up and forces down. I can draw this as a free body diagram, so I'm going to do that. I have the force of gravity down. What's my force up? Force of tension. The new kid on the block. That's really difficult to see. There. So I know that this thing is standing still. It's not rising up. It's not sinking down. So I know that the sum of forces on the y-axis equals 0. And I know that I only have two. I have the force of tension, and I have the force of gravity. This one's up, this one's down, so I'm going to write it like that. Force of tension minus force of gravity should equal 0. And we know that that means that force of tension is equal in magnitude to force of gravity. Shrink all that. And what that means is that force of tension is equal to mass times gravity, directed upwards. So that's easy. These are really easy when you have one cable. The ones that you're going to start to see in this unit, and then we'll do lots more of them later, are two cables. So let's set one of those up. Okay, so in this case, we have a slightly different situation. We have our mass, and we have our two ropes. How many forces are in play here? 3. So we have force of gravity, as always. And note that I'm going to draw these the way we draw forces in a free body diagram. The strings are not where we're drawing the forces. We're drawing the forces originating from the center of the object. And we have F of t, and typically we'll label F of t1, F of t2. And I didn't draw those equally, which is terrible. There we go. So we have 3 forces on this object. Is there any way to resolve those forces of tension because they're at angles? Only there was a way to break vectors apart into their component pieces. Yeah, of course there is. So for each of them we have, F of t1 on the y, F of t1 on the x, and I'm not going to draw in the F2s because it just makes it too crazy looking. So where can you go straight at finding force of tension 1? No, you can't. Because here's what you know. Now we're assuming a couple of things. We're assuming that theta 1 and 2 are equal. Oops. So it gets harder if they're not equal, because that changes, then you have two different forces of tension. As long as theta 1 and theta 2 are equal, so if theta 1 equals theta 2, then F of t1 equals F of t2. If those things are at the same angle, the force of tension in each line is going to be the same. If those angles are not equal, the forces of tension in those lines will be different. So, okay, we know that. What do we know about the x-axis? Is this thing, and you can look back to the original object back here, is it moving left or right? So the sum of forces on the x equals 0, which equals F of t1 minus F of t2. So we know that, F of tx1, F of tx2. So we know that F of tx1 equals F of t2x. Okay, you get it. I'm getting crazy with the subscripts here. And we can further say, if we're looking at this angle, the force of tension times the cosine force of tension 1 times theta cosine 1 equals ft2 times cosine theta 2. Okay, which is actual, okay, this seems like a dead end. I'm going to tell you that on number 5, this is going to save your life. The x-axis, especially if the angles are equal, the x-axis is like, yeah, okay, we know that, we don't need to do anything with it, blah, 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 set it aside. You end up doing almost a geometric proof on number 5. And it's a super challenging problem. And I actually, last year, had somebody solve it independently with a couple clues. Like I gave her 2 clues, and she went and did it. And I've very rarely had that happen. So I'll lay that out there as a challenge. We will walk through the entire derivation together after I give everybody a chance to see if they can get there on their own. So, okay, the x-axis is kind of dull. I'm going to set this aside. Let's look at the sum of forces on the y. Again, is it moving up or down? No. Sum of forces equals 0. Well, what forces do we have on the y-axis? F of t1 on the y, F of t2 on the y, and Fg. Which two are in the same direction? Yeah, the force of tensions. And they are in opposition to the force of gravity. Now, what do we know about F of t on the y? It's equal to force of tension sine theta. Well, we know that F of t1 equals F of t2, and theta 1 equals theta 2. So we can replace all of this with a simplified expression. What can we do?